Good morning. Welcome back to the session. See, in today's class, we are going to discuss temperature dependence of rate of a chemical reaction, or we are going to explain effect of temperature on the reaction rate. Effect of temperature on the reaction rate. Now, what is the effect of temperature on the reaction rate? How does temperature change the reaction rate? See, increase in temperature increases the rate of a reaction. In a chemical reaction, when we increase the temperature, rate of a chemical reaction also increases, or increase in temperature increases the rate of a reaction. For example, decomposition of N2O5. Decomposition of N2O5. So, N2O5 means dinitrogen pentoxide. Decomposition of dinitrogen pentoxide. Now, time required, I will write the temperature here. This is required time. 0 degrees Celsius, 25 degrees Celsius, other one is 50 degrees Celsius. At 0 degrees Celsius, required time is 10 days. Required time it is what? It is 10 days. At 25 degrees Celsius, required time, it is 5 hours. At 50, required time, it is only 12 minutes. I will repeat it once again. Time required to decompose 50% of N2O5. Time required to decompose 50% of N2O5 at different temperatures, it is like this. At 0 degrees Celsius, required time it is 10 days. At 25 degrees Celsius, required time it is 5 hours. Whereas at 50 degrees Celsius, required time it is 12 minutes. You can, if you observe these values, what we can see here? See, with increase in temperature, rate of the reaction also increases. When temperature, when it is very low, required time it is more. We need 10 days for 50% decomposition of N2O5. Slightly, if I increase the temperature, if I increase it up to 25 degrees Celsius, required time becomes what? It becomes 5 hours. Becomes what? 5 hours. Further, if I increase up to 50 degrees Celsius, required time it is what? It is only 12 minutes. What I can say from this? See, when we increase the temperature, rate of the reaction also increases. What is that reaction rate? Decomposition rate. Decomposition of N2O5 increases with what? With increase in temperature. Generally, in a chemical reaction, it is found that rate constant rate constant doubles when temperature is increased by a factor of 10, that is 10 Kelvin or 10 degree Celsius. Generally, in a chemical reaction, it is found that rate constant doubles or even triples also sometimes. So, rate constant doubles for every 10 degree rise in temperature. This is the general statement. Generally, for a given chemical reaction, rate constant it is increasing by a factor of 2. When temperature it is increased by a factor of what? Factor of 10. Now, we are going to explain effect of temperature on the reaction rate by using a theory. That theory it is called Arrhenius theory. By using Arrhenius theory, we are going to explain effect of temperature on the reaction rate. Let us explain that theory first. we are explaining Arrhenius theory. Arrhenius theory. Okay. Let us consider a simple reaction. I will consider H2 combining with I2 to give hydrogen iodide, that is HI, hydrogen iodide, that is 2 molecules of hydrogen iodide. So, let us consider a simple reaction, that is hydrogen combining with iodine to give what? To give hydrogen iodide. Now, according to Arrhenius, this reaction, that is formation of hydrogen iodide, it is possible only when collision occurs between the reactant molecules, that is chemical reaction. It is possible when molecule of hydrogen collides with molecule of iodine. So, chemical reaction, it is due to what? It is due to chemical reaction, it is due to what? It is due to collisions of the reactant molecules, that is formation of hydrogen iodide. It is possible only when molecule of hydrogen collides with molecule of iodine. Molecule of hydrogen collides with molecule of iodine. So, HI formation takes place when hydrogen molecule collides with what? With iodine molecule. See, collisions of the reactant molecule leads to a formation collisions of the reactant molecule leads to what? Leads to the formation of an intermediate. Collision leads to the formation of an unstable intermediate. That unstable intermediate, it is called as what? It is called as activated complex. Called as what? Activated complex. I will repeat it once again. Formation of hydrogen iodide. Formation of hydrogen iodide or chemical reaction. This chemical reaction, it is possible only when hydrogen molecule, it collides with what? It collides with molecule of iodine. Hydrogen, when it collides with iodine, what happens? Formation of activated complex takes place, or formation of an intermediate, unstable intermediate takes place. That unstable intermediate, it is called as what? Activated complex. Energy required for the formation of activated complex, that energy, it is called as activation energy. It is designated as EA, activation energy, or it is energy of activation, or activation energy. So, what is activation energy? It is the energy required for what? For the formation of activated complex. Energy required for the formation of activated complex. That required energy, it is called as activated complex. So, finally, this activated complex, since it is unstable, it readily undergoes what? Undergoes decomposition to give what? To give products. To give what? To give products. So, initially collision occurs. Collision leads to the formation of activated complex. It is unstable, so it should undergo decomposition in order to produce the product, that is 2 molecules of hydrogen iodide. Let us write it. Let us write the formation of activated complex and formation of the product by using the equation. See, this is hydrogen molecule. This is H2 combining with I2. Hydrogen combines with iodine. So, collision takes place between hydrogen and iodine. Collision leads to the formation of what? Formation of hydrogen iodide, correct? Leads to the formation of hydrogen iodide. This is activated complex. What is this activated complex? Or I can write HI here. This one I will write as H1. Okay, so collisions of hydrogen and iodine produces activated complex. Activated complex. This is activated complex. This activated complex has got high energy, so it is unstable. So it is not unstable. It readily undergoes decomposition. Undergoes what? Undergoes decomposition to give molecules of HI. 2 molecules of hydrogen iodide. 2 molecules of what? Hydrogen iodide. So hydrogen combines with iodine, or it collides with iodine, forming activated complex. To form this activated complex, sufficient amount of energy is required. That energy it is called as activation energy. Energy it is called as what? Activation energy. This activated complex, since it is having higher energy, it is unstable, so it readily undergoes what? Readily undergoes decomposition in order to give the products, that is hydrogen iodide, 2 molecules of hydrogen iodide. See, during the decomposition, some amount of energy will be released. Some amount of what? Energy will be released. So final enthalpy or delta H value for the reaction depends upon nature of the reactants. Depends upon what? Nature of the reactants and nature of the products. So while it undergoes decomposition, activated complex, when it undergoes decomposition, energy will be released. So what I can say, delta H value for the reaction depends upon whether it is positive or negative. Delta H can be negative or delta H can be positive. That depends upon nature of what? Nature of the reactants and products. So we can explain this by using a graph also, that is by plotting potential energy versus reaction coordinate. It is explained by using potential energy reaction coordinate, potential energy versus reaction coordinate graph. This is energy profile diagram. What is this? Energy profile diagram or energy barrier diagram. You can see the reactants here, that is hydrogen and iodine. This is the energy of what? Energy of hydrogen and iodine. So when these two, hydrogen and iodine, collide with each other, molecule of hydrogen, when it collides with molecule of iodine, molecule of hydrogen collides with the molecule of iodine, a unstable intermediate is formed. This is unstable intermediate. It is called as what? Activated complex. It is called as what? Activated complex. There itself I told you, to form activated complex, certain amount of energy is required. Certain amount of energy is required. So that required energy required for the formation of what? Formation of activated complex. That energy is called as activation energy. Energy is called as what? Activation energy. So if a molecule possesses sufficient amount of energy, then upon collision, it can form what? It can form activated complex. Afterwards, what I told you, activated complex, it is in higher energy state or it is unstable. So it readily decomposes to give what? To give the products, that is 2 molecules of HI. 2 molecules of what? HI. So delta H value, that is during the decomposition, energy will be released, correct? So that delta H value depends upon what? Depends upon nature of the reactants and products. So this energy change, that is delta H, that is what? That is delta H. Hope it is clear. I will explain it once again. What is Arrhenius theory? According to Arrhenius, chemical reaction, it is due to collisions of the reactant molecules. Collision leads to the formation of activated complex, that is unstable intermediate, that is what? Activated complex. Energy required for the formation of activated complex, that energy is called as what? Activation energy. Energy required for the formation of activated complex, it is called as what? Activation energy. activated complex, it is in higher energy state, it is unstable, readily undergoes decomposition in order to give what? In order to give the products. So, during the decomposition, some amount of energy will be released, some amount of energy will be released. So, delta H value for this reaction, that is delta H for the formation of HI, depends upon what? Nature of the reactants, that is hydrogen and iodine, as well as the product, that is HI. Next, we are going to explain why rate constant of the reaction increases by a factor of 2 when temperature is increased by 10 Kelvin. I will consider the same reaction. Say this is a gaseous reaction. We know that gases, they are made up of molecules. Gases, they are made up of what? Molecules. And all the molecules of the reacting species, will not have same energy, same kinetic energy. So, it differs from one molecule to another. So, all the molecules of the reacting species does not contain same amount of energy. So, in order to predict the behavior, or in order to predict the energy distribution among the gas molecules, scientists by name, one is Maxwell, other one is Boltzmann. Maxwell and Boltzmann, they used statistics. They used what? They used statistical curve. So, they used statistics in order to explain the energy distribution among what? Among the gas molecules. So, in order to explain the behavior of the gas molecule, or in order to explain the energy distribution, Maxwell and Boltzmann, they took what? They took statistics, and what they did is they plotted a curve, energy distribution curve, by taking, I will draw the curve here. This is fraction of the molecules along y-axis. Kinetic energy, it is taken along what? It is taken along x-axis. So, Maxwell and Boltzmann, they took what? They took fraction of the molecules along y-axis and kinetic energy along what? Along x-axis. On plotting fraction of the molecules, that is Ne by Nt. Fraction of the molecules can be written as what? Ne by Nt. Ne represents number of molecules with energy E, whereas Nt represents total number of molecules. Nt represents what? Total number of molecules. So, fraction of the molecules, they are along y-axis. Kinetic energy of the molecule, it is along what? Along x-axis. On plotting fraction of the molecules versus kinetic energy, they got a energy distribution curve like this. So, this is the energy distribution curve obtained by Maxwell and Boltzmann. So, energy distribution curve. Now, peak of the curve, what is this? Peak of the curve, this peak it is named as called as what? This is most probable kinetic energy. Peak of the curve corresponds to most probable kinetic energy. What do you mean by most probable kinetic energy? Most probable kinetic energy means kinetic energy possessed by maximum fraction of the molecules. Maximum number of molecules lie in this region, correct? Area, it is greater here. So, most number of molecules lie in this region. So, peak of the curve, it is considered as what? It is the most probable kinetic energy, means it is the kinetic energy possessed by maximum fraction of the molecules. Kinetic energy possessed by maximum fraction of the molecules, that energy is named as most probable kinetic energy. What about molecules lying here in this region? See, these molecules, they have energy lesser than this value, and molecules lie in this region, they have energy greater than this value, correct? Greater than this value. So, some of the molecules having lesser energy, some of the molecules they are having higher energy, and most of the molecules they are having what? Maximum energy, that is called as most probable kinetic energy. Hope it is clear. See, so peak of the curve, it is considered as most probable kinetic energy. So, there are some molecules with lower energy as well as higher energy than this value, most probable kinetic energy. Now, let us see what happens when temperature is increased. What happens when temperature is increased? So, when we increase the temperature, means we are supplying more and more kinetic energy. So, when we supply kinetic energy or when we increase the temperature, most of the molecules gain more and more kinetic energy. Molecules will gain more and more kinetic energy, thereby once their energy gets increased, these molecules get shifted from lower energy region to higher energy region, correct? They will shift from lower energy side to higher energy side. Understood? So, lower energy side to higher energy side. As a result, since molecules shift from left to right, what happens? Peak of the curve gets reduced. Peak of the curve gets reduced, whereas right side, this one, right side broadens out. Right side broadens out due to the shifting of the molecules from lower energy side to higher energy side. We can draw one more graph. Say this is at a temperature of T, I will take. This is at a temperature of T. When we increase the temperature, peak, that is most probable kinetic energy, I told you, peak of the curve gets reduced. Peak of the curve gets reduced and curve broadens out. This is the graph before increasing the temperature. This is after increasing the temperature. After increasing the temperature, this value I will take it as EA. What is EA? Energy of activation. Energy of activation. First curve, this is at a temperature of T. This is at a temperature of T plus 10. That is upon increasing the temperature. So, on increasing the temperature, more number of molecules will shift from lower energy side to higher energy side. As a result, peak. Initially, this was the peak. This peak gets reduced and curve what? Curve broadens. Curve broadens out. So, this was the initial fraction of the molecules having energy equal to EA or greater than EA. This is the fraction of the molecules having energy equal to EA or greater than EA, that is before increasing the temperature. Upon increasing the temperature, number of molecules increases. Fraction of the molecules having kinetic energy, that is having energy equal to EA or greater than EA, or number of molecules colliding with energy EA or more than EA increases. So, this is the extra number of molecules with energy equal to EA or greater than EA. I will repeat it once again. When temperature is increased or when we supply kinetic energy, most of the molecules gets shifted from lower energy side to higher energy side, from left to right. As a result, peak of the curve gets decreased. Peak of the curve gets decreased. This is the initial peak, that is at temperature T degree Celsius. This is upon increasing the temperature by 10 degree. So, peak of the curve gets reduced. This is due to shifting of the molecules from lower energy to higher energy. So P gets reduced. So when P gets reduced, on the right side curve broadens. Curve what? Curve broadens. So fraction of the molecules with energy EA or greater than EA increases. Without fraction of the molecules with energy EA or greater than EA doubles. Due to this, rate of the reaction also increases. So on increasing the temperature, fraction of the molecules having energy equal to EA or greater than EA increases. That is, when temperature is increased by 10 degrees Celsius, fraction of the molecules colliding with energy equal to EA or greater than EA doubles. So rate of the reaction also doubles. Rate of the reaction also doubles. Let us explain it once again from the beginning. So we started from Arrhenius theory, correct? So Arrhenius theory, what does it say? According to Arrhenius, chemical reaction, it is due to collisions of the reactant molecules. Chemical reaction, it is due to collisions of the reactant molecule. We considered a simple reaction, that is formation of hydrogen iodide. Hydrogen combining with iodine forming hydrogen iodide. So this reaction, that is formation of hydrogen iodide, it is possible only when molecule of hydrogen collides with molecule of iodine. Molecule of hydrogen collides with molecule of iodine. So collisions of hydrogen and iodine leads to the formation of unstable intermediate. That unstable intermediate, it is called as activated complex. So activated complex, it is what? It is an unstable intermediate. In order to form the activated complex, that colliding molecules must possess sufficient amount of energy. That energy, it is called as activation energy. So what is activation energy? It is the energy required for the formation of activated complex. Energy required for the formation of activated complex. That energy, it is called as activated complex. Activation energy. So activated complex, it is having higher energy. So it is unstable, readily undergoes decomposition in order to produce the products, that is 2 molecules of hydrogen iodide. So during the decomposition, some amount of energy will be released. What about delta H value? Delta H value for the reaction depends upon nature of the reactants and nature of the products. This is Arrhenius theory. Next, we went to effect of temperature. That is, when we increase the temperature by 10 degrees Celsius, rate constant also doubles, or rate of the reaction also doubles. So if we consider any gaseous reaction, gases, we know that they are made up of what? Made up of molecules, and all these molecules do not possess same kinetic energy. Do not possess same kinetic energy. So their energy varies from one molecule to another. In order to predict or in order to explain the energy distribution among the gas molecules, Maxwell and Boltzmann, they used statistics, and after studying statistics, they plotted fraction of the molecules versus kinetic energy. Maxwell and Boltzmann, they plotted what? Fraction of the molecules versus kinetic energy. Fraction of the molecules means Ne by Nt. What is Ne? Ne, it is the number of molecules with energy E. Nt, it is the total number of molecules. That is totally, that ratio we call it as fraction of the molecules. It is taken along y-axis. Kinetic energy, it is taken along what? X-axis. So on plotting fraction of the molecules versus kinetic energy, we got a curve, energy distribution curve. Peak of the curve, it is considered as most probable kinetic energy. Most probable kinetic energy means it is the energy possessed by maximum fraction of the molecules. Energy possessed by maximum fraction of the molecules. But there are some molecules with energy less than that value or higher than that value. Next, we shall explain what happens when we increase the temperature by 10 degrees Celsius or 10 Kelvin. When temperature is increased by 10 degrees Celsius or 10 Kelvin, number of molecules with energy EA or greater than EA increases. So as we increase the temperature, molecules gain more and more kinetic energy. thereby they will shift from lower energy side to higher energy side. As a result, peak of the curve gets reduced and curve broadens out, or number of molecules, fraction of the molecules with energy EA or greater than EA doubles, or number of molecules colliding with energy EA or greater than EA doubles. As a result, rate constant also doubles, or rate of the reaction also doubles. This is effect of temperature using what? Effect of temperature explained by using Arrhenius theory. Hope everything is clear. Understood? Thank you.